In the previous tutorial, we saw how to Dockerize a Django application using Docker and Docker Compose. In this tutorial, we are going to deploy our Dockerized Django application to a Linux server, more specifically a EC2 instance hosted on AWS. Before we get started, we need to prepare our Django application for deployment. And we can do that by changing a few things in our settings.py file. The first thing we need to hide is the secret key. As you can see that in production, we should keep this secret. And in production, we also need to keep debug false. And we'll also need to specify allowed host, which will be our EC2 instance public IP address. We also need to set a static root file where we'll host our static files. To hide this secret key file, we can use environment variables. Since we're working with Docker, we'll need to store this in an .env file. So in our root project directory, create a new file, and this will be called .env. And here we can store our environment variables. The first one is going to be the secret key. So secret key, this is going to be equals to our secret key over here. We'll also have the allowed hosts. Here we can have localhost 127.0.0.1. Eventually we are going to add our IP address that we'll get from our EC2 instance. Let me just remove the spaces. We also have the env. Env, this will check if we are running in production or development. I'm going to have it as dev. As I'm going to set the default to dev, which will stand for development. So in our settings.py file, we're going to need to import another package which will help us in reading our .env file. So we are going to install that package using pip, and that is pip install python.env. So I need to have that pip install python.env. So we have it, and we can add that in our requirements.py file. So I'm going to just copy that. You can just copy that in our requirements. Let's add that python.dev. Then you come back to our settings file and import it. So from .env, import load.env. So we can call this function, which will give access to our environment variables. So load.env. And here we need to pass our .environment path, and that should be in our root project directory. So we can formulate that path. So os path dot join. Here we can have our base directory, and we want to join it with .env. Then we can get our environment variable, which will check if we are running in production or development. So this will be equals to os.environ.get env. Then we are going to set our secret key, os.environ.get, and here we can get our secret key. As for our debug, we're going to set the default to false if env is equals to prod, else set it to true. So debug will be set to false if env is in production, else set it to true. As for our allowed hosts, we can get the allowed host key. So here we'll have os.environ.get, and that is allowed hosts. We can have the defaults, all IP addresses. And since this is usual list, we can split. So this is going to return a list of our allowed hosts as such. So we have our allowed host debug secret key. We also need to specify our static root, and this will be equals to os.path.join. That will be the base directory. and here we'll have it as static. So after that, you're going to need to edit our Docker file and YML file and add configurations for deployment. The first thing we are going to change, instead of running this command using python manage.py run server, we are going to run our application using Gunicorn and Nginx. Gunicorn is a Python with the HTTP server for running web applications. It allows us to handle multiple requests simultaneously by using worker processes which manage application workloads. As for Nginx, Nginx is a web server that sits in front of Gunicorn, handling client requests and serving statics file. It also directs our dynamic request to Gunicorn. So we are going to remove this. We can't have this in production, and we are going to install Gunicorn. So in our requirements.txt, let's add Gunicorn. We are going to use, in our YML file, we are going to add the Nginx image. But first of all, let's create our entry point. So in our root project directory, let's create our entry point file, which is a bash file. So entrypoint.sh, and this is where we are going to run our commands. So instead of waiting for our Docker containers to build, then execute commands like we did before, for example, run our migrations and populate our database, we are going to combine these commands into the entrypoint.sh file so that they can be executed during build. So the first command is usually our migrations. So we can have python migrate, and let's say no input. You can just copy this. Next command is going to be very similar, and that is the command to populate our database. So that is load JSON data, and we're also going to collect static. So I'm just going to copy that. Python manage.py collect static. What this command does is that it will go to every Django application, be it our application that we've created or our third-party applications such as the REST framework or Django's admin application, and it will package this statics file in our static directory, which we declared here in our static root. So we have that Python manage.py collect static. We've populated our database and we have made our migrations. So the next thing is to execute our Gunicorn service. So execute Gunicorn. Then we are going to point into our WSG application service. So that is backend.wsg dot application. Then we're going to bind port 8000, that is under 0.0.0.0.8000. Then we're going to specify 3 workers. So workers will be equals to 3. So we have this application, get with the application. Sorry, this should be a column. So backend with the colon application, bind port 8000 and set 3 workers. Then to our Docker file, we are going to define entrypoint. Entrypoint, this is an executable file which we just created. So sh up underscore entrypoint.sh. And with that, we are almost done. The next thing we need to do is to make this script executable. And we can do that using change modes in Linux. So run change mode. Here we can have it as +x. This will just make our entrypoint.sh into an executable. So this is up underscore entrypoint.sh. So before we conclude, we need to edit our YML file. We are going to edit our web container. Our salary bit is okay. Our DB image is okay. Our DB container is okay. So we just need to edit our web container. and add an Nginx container. So below the web container, let's have Nginx. And here we are going to specify the image which will be Nginx latest. We're going to say depends on, this will depend on web. We're also going to specify the ports. For now, we're just going to have port 80, which is HTTP. So we have port 80 and port 80. So we're also going to define volumes. And here we are going to bind our Nginx, our host machine Nginx configurations. So .nginx .configuration. We're going to create this file in a bit, and this file will host our Nginx configurations. And we're going to bind this in our containers etc nginx.conf.d and default.conf. So that looks good. We have our Nginx image, depends on web, specified our ports, we've specified our volumes. So I think the next step is to edit our web container. And here in our volumes, we are going to add another volume, which will hold our static files. So here we'll have static volume, which will be equals to app underscore static. We are also going to specify an environment file. So env file, our file name will be equals to .env. And this will enable Docker to access our environment variables. And we're also going to need to change our ports. Instead of binding port 8000 to our containers port 8000, we're just going to expose port 8000. That's because Nginx is handling our routing so far. So in our ports, let's delete it. Here we're going to have expose. There we're going to say port 8000. So that's okay. So we also need to allow Nginx to access our static volume. So in our volumes, you can just copy this from the web volume and paste it here in our Nginx and register that volume down here. So here we'll have our static volume. Yeah, that's okay. And that will allow Nginx to access our static files. So before we build our Docker containers, we need to define our Nginx configurations in this file, nginx.conf. So in our root project directory, let's create that file, and that's nginx.conf. So our Nginx for now are going to be very simple. And the first configuration we're going to have is server. I'm using the Nginx autocomplete. So inside my server configuration, I'm going to say listen, and that will listen to port 80 and port 8000, but for now I'm just going to remove port 8000. You can also have the location, our proxy pass, that's proxy pass. Here I'm going to have HTTP, and I'm going to point to our web container at port 8000. I'm going to set the header proxy, that is set header. I'm going to have it as host. The value is going to be variable as host. Then you can specify the static location. So location, this is going to be static, and this will allow Nginx to be able to render our static files. So alias, this is going to be app underscore static. Let's just have the / over there. And with that, our Nginx configurations are ready. We can now proceed to build our Docker containers. So we can do that using sudo docker compose app build. That will pull our new Nginx container that we just declared. It will use the configurations we just set, and it will proceed to build our container. So as it was building, I noticed an error in our Nginx configuration in line 17, and which is this semicolon. I think it's this, which is as a result of the autocomplete. So I can just remove that and rebuild it. So I'm going to stop this and build it again. So I'm going to build it again. Docker sudo docker compose app build. So our application built successfully. We have our Nginx container, our DB, our web. And when we navigate to our localhost, you see that it's working. If we go to our API, place, you can see we have all our players. And also the CSS is working, meaning our static files are being rendered by Nginx. And you can see we are not navigating to port 8000. It is just like in a real world application. You can also navigate to the admin page just to make sure everything is working correctly. And we can log in, but we haven't created an admin yet. So you can see that it's Nginx that's rendering the files. So with that, it's running well in our local environment. So let's see how we can deploy this to a server. I'm just going to stop this. So like I said before, we are going to deploy this to an AWS instance. So in your AWS console on EC2, we are going to launch an instance. So click on launch instance. Here we are going to give it a name of our server. Let's just call it my web server as suggested. And we can select Ubuntu. This you can leave it as default. Our instance type, you can choose any depending on your needs. But since this is a very minimal application for testing, we can just use our T2 micro. That's enough. As for our key pair, this will be responsible for logging into our EC2 instance. I'm just going to click on create new pair. You can have it as the default rsa.pem, our key pair name. Let's have it as my web server. So create key pair. Then it's going to ask for you to save it. Then in our security groups, we are going to allow HTTPS and allow HTTP from anywhere. And our storage, since we are using Docker, it usually takes more. So I'm just going to add 20 GB. And the rest we can leave it as default. And click on launch instance. So we should get something like this. Successfully initiated a launch of our instance. Click on it. It should redirect us to our instance. And you can see that it's running. So when you click on it, we are going to click on connect and select SSH client. We are going to use this to to copy our files from our local machine to our EC2 instance, and we're going to use SCP. We need to ensure our key is not publicly available, and that is by changing the mode to 400, and we can then connect to our EC2 instance using SSH. So I'm just going to copy this, and in a new terminal, let's copy that. And I've saved my key file in the previous directory, so that should be there. And after that, we can SSH into it using SSH using our key file. And let me just specify the path to my PEM file. Yes, and we should be able to access our server using SSH. So when we ls, you'll notice that we don't have anything so far. So in a separate tab in our local environment, I want to copy my local files and upload them to our server. To do that, there's a couple of options, and one of them is using SCP. But since we have a virtual environment directory over here, which consists of basically unnecessary stuff, since we can always create a new virtual environment in our server, I don't recommend using SCP for this use case, and that is by using rsync. So it takes the following structure, where we will have rsync exclude VNV and SSH. Here we're going to provide the path to our key file .pem. Again, that's this, my web server .pem, and path to my local directory. Here we can just pass the path to our directory. Mine is home, Byron, and that's under Django backend. Then in my EC2, we can just copy the path to our EC2 instance. So we can just copy this path, Ubuntu at this. So I'm going to delete this and paste our EC2 address, Ubuntu at that. Here I'm going to add this path, EULA, and /, which will indicate the home directory. So that has worked. It has sent all our files to our Linux server. I think I should have also excluded the static files. Or the other option was to just create a Git repo and clone it in our Linux server. But that would have involved configuring SSH keys in our Linux server, then adding them to our GitHub repo. We're going to see how to do that in the next tutorial. So now that we have that, and when we look at our files, you'll notice that we have our directory there, Django backend. So we can seed into Django backend. And yeah, we have all our files. What we need to do now is to install Docker and Docker Compose. And we can do this by following the instructions from the official documentation. I'll have this link in the description. So we can test it by running this command, copy, and paste it. And yeah, we have Docker running successfully. We're going to use the official documentation of installing Compose standalone. So let's just copy this. This will install the latest version. I think we need to do it using sudo. So sudo. We have that has been installed. And The next step is to apply executable permissions to the standalone binary in the target path for the installation. And we can do that using this command, chmod +x, and that will make our Docker Compose executable. Docker Compose version is that. So that is working well. Let us try building our Docker containers. So we've done this before, and that's sudo Docker Compose app and build. So that will build, but it will not be able to access it till we've modified our allowed hosts, Django allowed hosts, because at the moment I think we are only allowing localhost and 120. We are only allowing localhosts. We are going to need to add our IP address to the allowed hosts. So we verified that our build is running well. So I'm just going to stop it for now and update our configurations so that we can be able to access it. So nano nginx.conf, and here we are going to have another variable. This variable is going to be called server name, and this will be equals to our public IP, which you can get it from our instance. Just copy the public IP and paste it in. So our server name, we are listening to port 80, static and whatnot. So we can save that. Then you're going to edit our allowed hosts, and that's in our backend. No, that is nano.env. In our allowed hosts, let's just add our public IP and paste that in. So Control X. Yes. So before changing debug to false, since we are in production, we're first going to test it to make sure everything is okay, everything is running correctly, so that we can finally change it to false. So we can build our applications once more. So sudo docker compose app build. So that is running correctly. If I navigate to our public IP address, you'll notice that we have everything working correctly. If we go to our admin page, we are able to log in using our email and passwords. But for now, you can see that we haven't added our SSL certificates. That's why you have in this error. At the moment, we only allow HTTP. In the coming videos, we are going to see how we can get a domain name for our application and maybe add SSL certificates. So you will notice that even though we have our application running correctly, we can log into the admin page. But when we navigate to our player's endpoint, we don't have anything. And that's because when Celery and our web application tried to populate the database, our Celery container got killed. And that's because of memory constraints. And that's because I decided to use a rather small EC2 instance. If you encounter this error, you can consider increasing the memory size or choosing a bigger EC2 instance. I'm going to do that before deploying this application, I'm going to use a bigger EC2 instance with more memory, because what it chose is very small. It just had 1 GB of RAM. So I'm going to stop this, and I think that's it for this video. Let me just show you one more thing. If you want to, you can build your containers without displaying all the verbose log by adding the detach mode, and that will, after it has finished building up your application, it will free up your terminal and you can continue doing other things as your application runs in the background. So that's it for this tutorial. We've seen how to deploy Django application using Docker, Gunicorn, and Nginx. In the next tutorial, we are going to optimize it further, maybe add a custom domain, SSL certificates, and so much more. Thank you for watching. See you in the next one. And if you found this video useful, consider giving it a thumbs up and subscribing for similar content. Thank you.